Hello everybody, today we are going to continue with a review of important concepts of Algebra 1, and today's objective is how to solve system of linear equations into variables. So let's see what the system is. System of equations is a set of two or more equations that use the same variables, and the linear system is a system where the graph of each equation is a line. And usually we want to keep the equations together, so we use the brace. A solution of a system of equations is the set of values for each variable that makes all the equations true, both of the equations true. And one way of solving the system of linear equations is graphing. It's a more visual way because you could see the solution. The solution is actually the point where graphs intersect. The other two methods are substitution and elimination, and they're more algebraic, where you have to use arithmetic operations to eliminate the variable or to substitute for one of the variables to get the answer. So what about graphing? Graphing is not the best method if you need an exact solution, but graphing is often a good method to help solve contextual problems or visualize the answer. Let's take a look at this particular example. We have to solve the given system by graphing x plus 3y equals 2, 3x plus 3y equals negative 6. So the first step there is to solve each equation for y. That means you have to write an equation in a slope-intercept form. So x plus 3y equals 2. To solve for y, I would have to move x to the other side. I would have to subtract x to both sides of the equation, left with 3y equals negative x plus 2, and then I will divide everywhere by 3, so I will get y equals negative 1/3 x plus 2/3, and I'll leave it in the fractional form. Next equation is 3x plus 3y equals negative 6, so to solve for y, I would have to minus 3x to both sides of the equation, or add negative 3x. Then I will divide everywhere by 3, so I end up with y equals negative x minus 2. The next step is to graph. Let's take a look at the graphs. The first graph, the red graph, is a graph of the first equation. As you could see, the y-intercept is 2/3. We kind of estimated where 2/3 would be. And to graph, I can go one step down and 3 steps to the right, or one step up and 3 steps to the left. Remember, we use the rise over run for the slope. And if I go one step up and 3 steps to the left, I will end up somewhere over here. And once I connect the points, I will get the red graph, a red line. Next one is a lot easier because your y-intercept is negative 2. I start at negative 2 and the slope is negative 1. So I go one up, one to the left. And when I connect those points, I will get the blue graph. Now to see where the intersection is. The intersection is right here, the point negative 4, 2. So now see if that's indeed the solution. In order to see, I would have to check. Check by plugging in negative 4, 2 into both equations. They both have to be true. So plug in negative 4 for x and 2 for y. And if you plug into the first equation, as you could see, the answer, it will check off. It will be a true statement. And if we plug in negative 4, 2 in the second equation, you will also get the true statement. Now, the next method is algebraic. It will be a substitution. So the word about substitution. Substitution is a good method to use if one variable in one of the equations is already isolated or has a coefficient of 1. That means stands by itself. Substitution can be used for a system or 2 or 3 equations, but many, including me, prefer solving the 3-equation system using another method, which is elimination. So let's take a look at this example. I want to solve this system by substitution, so I would follow the next step. Step 1 is solve the equation for one variable, put it in a y equals, x equals, and so forth format. Then substitute the equation solved in step 1 into the other equation. Then you will solve what you get and plug the answer back into one of the original equations to find the other variable. But remember, the last step is always to check your solution by substituting your ordered pair into both equations. They both have to be true statements. So let's take a look at this example. Y equals 3 plus x. This one is already solved for y. So I will use that equation in step 1. It's already solved for y. So I will just substitute it into the first equation. As you could see, in place of y, I substituted 3 plus x. And when I solve that equation, I end up with x equals 1. Now I take x equals 1 and plug it into one of the original equations, and the easiest one is the first one. So if I plug in x equals 1, then y clearly has to be 4. And my solution is 1, 4, but hold your horses. You have to really plug it back in to check. And I plug it into both equations to check, and they're both correct. So I could say that the solution is 1, 4. So what do you think the answer would be if you graph two equations? Guess what the answer will be? And you are 100% correct. The two lines will intersect, and the intersection will be at the point 1, 4. Solve system by using substitution. How about this one? And again, in the first step, you already have x equals 3 minus y. So the first equation is already solved for x. So you are going to just substitute it into the second equation for x. And guess what happened? Negative y and positive y got eliminated. And so you end up with 3 equals 7, which is a false statement. Guess what? When we get a false statement, that means we have no solution. So the intersection of that, there would be none. So then the lines must be parallel in the picture. Now let's take a look at the next system. This one is not, none of the variables isolated. So then here's y. This variable y has a coefficient of 1. So I'm going to solve by that variable, solve the first equation for y. So I would subtract 2x from both sides of the equation. So I end up with y equals negative 2x plus 4. And then I substitute that y right here. But remember, there's a coefficient 2, so you have to distribute the 2. Once you distribute and solve, 4x got completely eliminated. So you end up with 8 equals 8. But now the statement is always true. And so if the statement is always true, that means we've got infinitely many solutions. So the answer has infinitely many solutions. A word about the next method, elimination. Elimination is sometimes referred to as linear combination in some books, and it works well for systems of equations with 2 or 3 variables. And I prefer using elimination when I solve systems of 3 variables, of 3 equations. So far, we have solved system using graphing substitution, and let's finish the notes by looking at elimination method. Elimination method uses addition and subtraction as its core. So elimination, I think, is the easiest when the equations are in the standard form. So first thing I would do, I will put both equations in the standard form. Then I will determine which variable to eliminate. So you're looking for the variables with, so to speak, same coefficients. It could be literally same coefficients, or it could be they could be opposite coefficients. And then you would add or subtract the equations that would eliminate that variable for good, and then you will continue solving. And whatever you get, you will plug in one of the original equations. And remember, the last step is always check for your solution. So you are going to replace the substitute, the ordered pair you've got, into both equations, and they both have to be true. So let's take a look at this example. As you could see, the coefficient in front of y in the first equation is 1, and in front of y in the second equation is negative 1. So they're, so to speak, same coefficients because they have same numerical value and the opposite signs. So then all I have to do is add the equations. Once I add the equations, y is eliminated for good, so I end up with 4 equals 12, and I get x equals 3. Now I will plug it into one of the original equations. I will choose the first one to solve for y, And in this case, y equals 2. So my ordered pair is 3, 2, but I cannot say that that's my solution unless I check. And I just did check, and they both equations end up being true. So then 3, 2 is the solution. So what do you think the answer would be if you solve using substitution? And you are correct. The answer will be exactly the same. So let's take a look at the next one. I'll put this equation in the standard form, and they both are. And so next step is to determine which variable to eliminate. You could see you can eliminate 4x because they have 4, the same coefficients. But in this case, I would subtract. But be very careful. Remember, subtracting negative numbers, you have to use keep change rule, because subtracting negative 2y will be actually adding 2y. And subtracting negative 2 will be actually adding 2. And in this case, y equals 3. So then when I plug it back into the equation, all I have to do is solve. And I get x equals 1. And the very last step is to check your solution. As you could see, you have to plug in 1, 3 as x and y into both equations, and both equations have to be true. And they are. And that concludes our videos. Thank you very much. Have a great